Hello and welcome back. I've been on holiday the past 2 weeks, so I haven't uploaded any videos, but now I'm back to recording. Last time we were still working on AlphaZero on Stackit, and today I thought I want to change the topic. Even though the AlphaZero implementation was not finished in the end, I want to now do a session about data analytics with Claude Code. At my normal daily work, I already use it all the time. Claude is very good at writing SQL and querying BigQuery and discovering data. And today I just want to give a taste with some simple examples. One example we're going to look at is the Titanic dataset from Kaggle. I know it's a very simple and actually maybe chewed out dataset, but I think just because of the simplicity of the dataset, we have more time to focus on the process. I hope I can show how Claude can work with CSV files. After this, we will actually do an example where we use a more complex dataset. Let's jump right in. Here I'm just gonna try to have Claude just read the whole CSV file into context, and then we ask it questions about it. This is very inefficient and doesn't really scale to large data sets, so this is not something you should or can do. I just want to show that, you can do it, but you shouldn't do it. I just want to show what happens if you were to do it, so read at, where is it, data, Titanic, train CSV. I thought by adding, now it read this data set into context, and since it's not a very large data set, we can see that the context went from 32,000 to 54,000 to 74,000. Okay, now it's maybe filling the context. But you can already see Claude is already smart enough to say, okay, now I read this whole file into context. But instead of just trying to answer any questions from memory, it was already writing Python code to get some summary statistics of the data set. So it was outsmarted me here. This is actually how you should work with data. Instead of reading the whole data set into memory or into the context, I think it's better to ask Claude to write code and do summary statistics about it. I read the whole file. Here's what's inside. 40% of people in this file lived. This is the various columns that we have. And there's some missing data. 74% of women lived, 20% of men lived. First class was more likely to survive than third class, and so on and so forth. Make charts, train a model. So, this data set is already part of the training set of Claude. I think Claude probably trained on lots of Kaggle and Reddit data around this data set. So I think a lot of the knowledge we are using here is already baked into the classifier, and then start fresh by asking it to do some summary statistics of the data set, because I want to preserve my context. Right now we loaded everything into the context, and I think this is wasteful. So I'm going to clear it now, and I think technically if you want to work with data, you should never ask Claude to read the whole data set until it's very small, unless it's very small. Can you about the summary statistic and interesting. Okay, this is very generic and might not necessarily work on your production setting, but asking summary statistics is okay, but interesting insights is very open. I think usually when you have your own data set, you probably have some more concrete question that you want to ask. And here we could have asked, give me interesting insights about art that I want to talk about is charts, a small visual report. This is something that's very big. If you have your own data set right now, it's pretty much free to make dashboards or charts. And then maybe we also produce a machine learning model. Yes, it would be nice if you could generate an HTML dashboard which visualizes the data and the trends in the data and gives an interesting report that I can send to a third party It's the data analysis part. Let me quickly pause. I want to think whether we continue with this data set. We can now actually ask Claude to build a machine learning model, for example, or whether we switch the data set, because I have a second data set which is more complex and more complicated, and I want to show you how to do data analysis here too. Okay, I'm back. I decided that the second part of this video we will actually keep looking at data. I downloaded another Kaggle dataset, so Claude most likely already trained on something like this too, but it is more complex. You can't just read all of this in memory, and maybe some of you might know it. It's called Home Credit Dataset or something, and it was a dataset where we should predict whether somebody will default on their loan or not. Same here. I will now just tell Claude to investigate this dataset. Wait. In the dataset folder we have a home credit dataset, and I want you to tell me what files / tables we have there, and what the dataset is about. I never seen this dataset, so I think maybe we will have some more interesting questions we can ask Claude about this dataset. Also, while preparing this episode, Claude mentioned to me that maybe we should use DuckDB, because I also wanted to show Claude is actually very proficient at writing SQL and not just reading CSV files. So what the data is about: home credit lends money to people. Many of these people have little or no credit history. Will this person pay the loan? Okay. Here also we get recommended DuckDB. Let's try this. I never used DuckDB. Maybe it's fun. I like the first option, starting small. Yes, let's start small. Look at the application, train CSV. Tell me what's inside and do some data analytics on it to tell me what we have. As always, since Claude sometimes works for minutes and we never know when it finishes, I will pause the video and be right back when Claude is done. Okay, we are back already, and Claude gave me a lot to read, so script ran clean. What's inside? We have 300,000 rows. One row is one application, no duplicate IDs. Very good. 122 columns. Target is very balanced. Unbalanced. Only 8% are one. I think actually 8% sounds like a lot. The imbalance matters. If you guess everyone pays, you're right. Yeah, okay. This is the typical don't use accuracy as a metric. We won't. Missing data. Okay, columns have holes. 41 columns are more than half empty. Okay. 2 traps in the data. Days employed. I guess this one is actually a filler value or something. So what I want to highlight here is I think it's really cool to see how Claude figures out these edge cases. I mean, it checks for missing data. It finds that there's a funny value in this column. Not employed, replace it with none. Yeah. Amount, income, total, max is the 9 is only, so that is one crazy outlier. Capital used log. Okay, dates are stored negative days from start. Means okay, so all of this is great. We already know a lot about our data. Of course, you have to be careful because you never know whether Claude found every possible thing, but I think just by telling it, hey, look into this data, we already get a lot of useful insights. The strongest columns by far is the external source 1, 2, 3. These credit scores from outside sources. So also this. Now looking at it, external source 1, 2, 3 makes sense. It could be some external credit scores. Sometimes Claude makes up these reasons though, so you should always bring a little bit of knowledge. And let me quickly open this and see if there's any description of that column. I don't see it here. No, it is here. 1 second. External external source 1, 2, 3. 1 second, I just EFG here. Normalized score from external source data. So actually it seems the CSV file has column descriptions maybe somewhere, but these are indeed credit scores. That is a 7x spread, nothing else in the table comes close. Age is the next best thing. So, I mean, for me, also amazing, it immediately does something like a univariate analysis, right? So, we find that the default rates by age are actually very different. So if you're old, you're defaulting a lot less than if you're young, which is maybe, I could imagine a scenario where this is true because, you know, younger people maybe don't have money yet and are maybe more likely to be irresponsible with money. Who knows? Smaller but real signals, men default more than women. Of course, if you build a classifier and you use this as a feature, you should be careful because you might generate a biased classifier which makes you vulnerable to lawsuits. So I'm not sure gender is actually a feature you could use. Lower secondary school versus higher education, academic degree, lives in rented flat versus parents. What surprised me? Okay, Claude has a surprise. Loan size and debt to income barely matter here. Interesting. I binned both into 5 groups. The default rate stayed in every bin. The biggest loans actually default least. Why? The bank already screened those people. Okay. I'm not sure this makes sense because, you know, we are supposed to screen this, and of course you could say because historically we accepted those people, there was some sort of screening done, and the loans that we observe here are only the loans that were taken. This is also something you have to consider if you build this for a production setting. Are there rejected loans in here? Because if not, you're actually excluding already a large part of the population. So all of these loans are already credit worthy according to some person's credit score. Clean and build a baseline model. Look deeper into the main table first. Charts of the top columns and dig into organization type and flag document. So I like this. I think in order to actually make a good model, we should push a little bit deeper into the data set. And this is exactly what I will ask Claude to do. Let me quickly check. I had one particular question when reading all of this, or some claim that I thought was not correct. Are there actually any rejected loans in this data set? Because you maybe rightfully mentioned the bank already screened all of those loans. So probably all by the current credit policy, all of those loans are loan worthy. And now we are building a classifier on top of this to further refine initial decisions made. As far as I understand, we also only looked at one of the CSV files, but we have multiple files left over. I think we should dig into those as well and see how those files join together and generate more insights into the loan applicants. Then you also mention organization type and flag document columns. This is also something I want you to look at. At the same time, since we may or may not run out of context, I want you to document all of your findings into a markdown file. Keep it very brief so that we save tokens when we read it in later sessions. It should mainly store which columns, which correlations we found, or which important insights, but not too much text around it. Maybe just how it was calculated. Okay. Now we let Claude work on this and we come back when Claude is done. Okay, we are back. We can see Claude has been running many analyses, wrote a findings markdown file where it keeps all the interesting things, like I told it to. One thing I noticed is it added this line about light GBM, and I do wonder if it already started running some training experiments, even though we didn't tell it to. Okay, application train has 0 rejected loans. Okay, every row has a real credit amount. Okay, second filter, rejected loans do not exist. But in previous application CSV, we have something like this. Rejected loans do exist. Yeah, okay. By the same people, so you can ask, was this person rejected before? And that's what it did. So, it found that we have previous applications, we have past rejections, and then the more past rejections somebody had, the higher is the default of a loan that we then eventually accepted. Then credit card usage is the best new number I found. Amount balance divided by credit limit. How full is the card? So again, here I really like that Claude uses its baked-in knowledge to do some feature engineering instead of looking just at the raw features. Correlation, that's the second strongest thing in the whole data set after the external sources. Bad news, only 28% of people have a credit history. Paying installments late, more than half late. Okay, having no credit history at other banks is bad. Yeah, obviously, because A, we don't know anything about you, and B, it might mean that other banks rejected you. Microloans everywhere, red flag. Your 2 questions, organization type, safe, police, military, bank, school, university, risky, transport type 3, restaurant, construction, self-employed, strip the N suffix, you get 15 clean groups. Okay, flag document, 18 of them are junk, 16 fire, okay, 6 fire, pure noise. I wonder what flag document means. So this is where we should ask Kaggle again. Entrance modes. Flag document. Yeah, so the client is asked to provide certain documents on application, I guess, and these flag documents _123, they only tell us whether the client provided this document or not. Drop the rest. What to do now? Build a feature table and a light GBM baseline. Charts first, plot the top 10 findings. Yeah, I think for this particular example we don't need plots, but I'm also not sure we are completely done yet. Have we already looked through all of the files? And actually, yeah, no, we shouldn't mix it. I wondered whether we should maybe install DuckDB, because one reason I wanted to take this data set is because I wanted to install DuckDB and show that Claude can write SQL as well. But since we are in the middle of this model building adventure right now, I think we can just keep pushing a little bit. So now I will let Claude investigate the remaining 3 files, and when we come back we can maybe ask it to produce the first classifier. Okay, Claude finished. Wrote the findings document. All 10 files are done. Sample submission. Okay, this is not so interesting. Column description. It seems only now did it read this, so somehow it understood that these are credit scores. Days late with tolerance. That explains why it beat plain SKDPD. It measures at application date. Okay, surprise. Train and test set are not the same. Test set almost doesn't have any revolving loans. And certain other features. The revolving loan drop is the big one. Your training data has, test set has almost none. Also 12 of the 20 flag document columns are all 0. Good news. Age, income, and employment all look the same in both. No ID overlap. Only 3 tiny categories. What to do now? Yeah, so personally, I'm quite happy with this. We can open findings, markdown file. Can I open this? Okay. Home credit finding, schema join, so we can see Claude identified the ID that all of these files join together. Rejected loans, key farming, approved, rejected, strongest signals. This is also very nice that it listed those per table nodes. All of the interesting data insights it found per table. Sample submission and modeling. Without reading all of this on screen here, I feel like we can move on and let Claude build one of our baseline models. So yes, I want you to build a light GBM baseline. Use everything we found so far. Try to find a good train and test setup. About the test set imbalance, or yeah. So one thing I wondered is maybe those flag documents are not collected on cash loans, but only on other loans. That's why they might always be null. And while for the particular task at hand, it might be good to drop all of those columns. If we were to build a model that should work on all of our loan types, I think it might be worth including them. And it missing might just be people not submitting them. Again, probably depends on the loan type, which documents need to be submitted. And I mean, there might be other factors. So, you know, in certain risk scenarios, we might collect more documents. I wonder if providing more documents correlates with less delinquency. Not sure we can see which of the rejected loans had which documents provided. But if all of this is complicated, I think at least for version 1 we can ignore those features and use the other features that we have to build a good baseline. As for metrics, I think ROC AUC is not going to be great, so we should use PR AUC. And maybe I expect a small HTML report that shows me train size, test size, if you do cross-validation, what was the number of train and test samples in each fold, what was the performance of each fold, what's the average performance across folds, what's the final model performance that we expect, and maybe Shapley values for features. Yeah, maybe just a really small HTML report. Maybe we can also have a table that shows the top false positives and false negatives. Okay, I think this is a bigger task. I will let Claude run on this task. Since we are already at 30 minutes, I think this then also concludes the video. We will still look at this HTML report once Claude is done, and then we will wrap it up and do more in the next video. Okay, Claude is done. It confirmed part of my document hypothesis that documents are tied to a loan type. Cash, like document 3, is available for almost 80% of cash loans. Not a risk signal. Okay, wrong. Does not explain that 11 columns, not supported. We're thinking, okay. And then it built 240 different features from all 7 tables, light GBM, 5-fold cross-validation, 0.284 PRAUC. Yeah, I think these metrics we can maybe hopefully see in one of the plots. Keep all rows, the drift test comes back. Okay, this is maybe worth thinking about a little bit more, but I wanted to show the HTML report that Claude made. So I mean, you can argue about the format and everything, and you can adjust it however you want it. For like a one-off, this is fine. 0.28. Not sure how we get the expected out of out of fold, PRAUC. Out of fold, rock AUC, train rows, test rows. Okay, this section I wouldn't need, to be honest, so I would ask Claude to drop it. Here we have the different folds. Train or contract types, best iteration of the classifier. They are all pretty stable across folds, so it doesn't seem, I mean, maybe they were randomly chosen, then it makes sense. If they were chosen by point in time, then sometimes we can maybe see very big swings. Test set mix problem. Train is 9.5%, revolving loans default. So score measured on the full train mix is not what test will give. So, not sure. Like this whole thing, I'm not sure Claude is overweighting this. I would ignore it for now, but if we continue, we have to really think about what it's saying here and maybe push back on it. The credit bureau extract was refreshed between train and test set. Adversarial. A classifier asked only, is this row from the test file? Would mean the two files are drawn from the same distribution. Okay, it seems we don't have a random split between training and testing. The cause is coverage, not risk. Bureau balance history is missing for 70% of training clients, but only 10% of test clients. Okay, so there seem to be certain features that may be available in train and not in test, so we can easily distinguish the sets according to it. Little unique sample price robustness recommended for any model that must run on future data. Okay, so this is also something to think about a little bit more. Precision recoil curve looks like this. This is not particularly good as precision recoil curve, but maybe for credit risk, kind of what you expect. Depends on your features and data. I don't like that we don't have any, like this should be interactive or something, so we can actually see the various thresholds and precision and recall. But it seems to me maybe 20% recall on, yeah, here we have 50% recall, 23% precision. Depends on what you want to do with this score, right? So, I mean, in one of the next episodes, we can maybe talk a little bit more about credit scoring and develop our own credit score system with Claude. Feature importance, external mean. So these two features are definitely very strong. That's the external data. I mean, you know, if we have a credit score from a third-party provider, this is going to be very strong. We do use gender. Apart from this, it doesn't seem like there's a God feature. One thing we should check is if these external features are actually available similarly in train and test. Sharp B swarm. Okay. Yeah, if your credit score is high, your risk is low. And that makes sense. So you could look into this in detail. Worst false positives. Prediction is high, but actually not defaulted. Would be something to look into more. Maybe we should add Shapley values for these as well to see why they were like these worst false negatives. It seems to be mostly old people. We are underperforming maybe on old people and on young people that do not default. So, you know, there might be some bias in the model here, which we could look at. Setup and caveats. Yeah. So, I think that concludes this episode. We did some data analysis. To be honest, I really want to find a SQL example too, because I'm always in awe how easy Claude writes SQL statements and executes them and really digs into tables. But for now, we just let it investigate some Kaggle dataset. I mean, we could now upload this classifier and see how much we score on the leaderboard. I wonder if that's still possible, because it's a very old competition. I think in one of the follow-ups we could try to improve this classifier, but I'm not sure. I think for me, mainly this episode was about data analytics and like really letting Claude hash out, finding features, finding data, finding insights. Um, I hope it helped, and if you have any suggestions for how to improve these episodes, let me know in the comments. Thank you very much.